and they shift the value of one quarter to the another value. Each quarter of the square matrix is used to generate the one coordinate for the newly generated key matrix based on the quarter equation. If we simplify this summation equation, we will find that with this quarter value, after this quarter value, will get only the single value. By using this single value, we see that we have a 4 quarter, we will get the 4 different coordinate. In other words, we say that with the 4 quarter we will get the 4 different coordinate. In other words, we say that we generate the one row for the each matrix using this triangular coordinate extraction technique. And similarly, all the 4 equations are used to extract the value and generate the one coordinate using this primary and secondary diagonal intersection algorithm. For detail, you may search out the research paper Triangular Coordinate Extraction for Hybrid Cube, which is published in the Journal of Engineering and Applied Sciences. Here are the input key matrices, or referred to as a state, are structured into 4x4 matrices. In this regard, we are generate the 24 key matrices. I will tell you why we need to design the 24 matrices for the generation of 6 faces of hybrid cube. In previous slide, we see that with the one face of hybrid cube, here is array which contain the 16 coordinate. 16 coordinate mean 4x4 matrix you have. After the 4x4 matrix, you have generate only the one row in the newly generated matrix. Similarly, for the second matrix in the hybrid cube, we using the triangular coordinate extraction technique. After that, we will receive the second row of the single face. Similarly, we use the third matrix of hybrid cube, and after that we generate the third row of the face 1. Similarly, we see that the fourth matrix of the hybrid cube, using that we generate the fourth matrix. Because of the 4 key matrices of hybrid cube, we generate the single matrix of newly generated matrix using the triangular coordinate extraction technique. Similar process we applied to the all other 4 matrices, and we generate the phase 2, next 4. After that we will generate the 6 phases. Before I say that, why we use 24 matrices? 4 matrices are used to generate single phase. For 6 phases, we use 6 into 4, 24 key matrices. Because of that, we are using the 24 matrices for the generation of one key matrix. The generated Q matrices are used in the subsection for this shift column on transformation. Now here is the brief. The input of key scheduling algorithm can be considered as n. The m and iv are considered as the predefined string of integer number, and p of j is also obtained from the user. Pj is the password. Password we are taken from the user. The overall input of the addition of initialization vector, iv is the initialization vector, and pj into password. That result is modulo with respect to m, which denoted as column, which denoted as the resultant value, which is the column row resultant value, and can be represented using this equation. You will find the CRG value of column row selection value. Next, you see that here we differentiate with ABCD. With the first 4, the integer of this resultant value are used for the initialization phase of column rotation, and the last 4 W, X, Y, Z are used for the initialization of row rotation. Why we need the column rotation initialization phase? Because if we see that in the hybrid cube we have different color combinations, 6 different faces. If we use the single face of hybrid cube, you see that if we use we mention the numbering on the each face 1 2 3 4, and the left is fifth and right is sixth. Maybe if the initialization column is the face 1, then we will say that okay, 1 is our front face, upper face is 2, back face is 3, down below face is the 4th, and left will be the 5 and right will be the 6th face. If we have suddenly with the password and after the CRJ value generation, if we get after this calculation the face value 5, if the face value 5, you will see that then we move to the cube into to the 5, then you see that 5 2 6 and 4 is the combination. This is why we need the initialization, why we need to add the complexity in the rotation of face in the column rotation. Similarly, in the raw rotation side, we also say that we also see that we add the different numbering in the 6 faces of hybrid cube. Based on that, based on this equation, we will select that where to start the rotation of the hybrid cube. Next is the shift column rotation algorithm. The definition, which is the shift column rotation, is the transposition of column vector that cyclically shift the column of each face over the different column offset of the hybrid cube. It's other word, we say that cyclically rotate the hybrid cube of the hybrid cube. If we rotate the one column, it will affect to the second, third, fourth, all column, and even though if we rotate the first column and the last column, here you see that the last column, here you see the first column. If we rotate the first column, then you see that the left face is the orange color, which also rotate, which also move in the anti-clockwise direction. If we see that in the fourth face in the hybrid cube, you will see that if we rotate the anti-clockwise or to this column, then we see that the sixth face in this one is show that the red color face, which also represent the movement in the clockwise direction. In the first column, we see that with the invertible anti-clockwise rotation of column, and the quarters are rotated using the anti-clockwise, where the column anti-clockwise rotated, but the quarters are rotated in the clockwise direction. Due to that, we this research further proposed that if the different faces of a cube having first and fourth column, then the value of the lambda equal to 1, otherwise the value of the middle column value is lambda equal to 0. The equation can be set as this. We move 1 to 4 value, we have 4 different faces, and 4 into rotation mean each rotation it rotate 4 times. The ith rotation, we say that if one time rotate, the rotation of column value we taken from the previous slide. In previous slide we see that we will move back. Here you see that we have a value, we say that first 4 used for column rotation, last 4 used for raw rotation. If the a value, here the value is 1, for example, if the value is 2, okay, a is a value of 2, 1, 2, 3, whatever the value. Whatever the value is 2, we say that in here first column is rotated with the 2 time. Second column, second value over there mentioned CRJ, second value mentioned is 1 time rotated, we have rotate 1 time. Third is 1 time, for example. Fourth, we maybe say that 3 time rotate, then we will rotate the 3 time. Whatever the value is selected by the user of the password after the calculation CRJ value we receive, then accordingly this is the dynamic structure, how many times all the column will be rotated. C value is after the quarters, we say that the lambda equal to 0, y was 0. Second and third column rotation, you see that no left and right movement of the faces of the hybrid cube. Due to that, we will manage if the value of we use the second and third, then we what we do is we will give the lambda value will be the 0. Here is the algorithm that designed for this shift column transformation, and this is what the case 1 and 2 is. That case 2 is that if we select the phase 5, then we see that if phase 5 we have a combination 2, 4 and 6, and left become the 3 and right become the 1. If we use the value IF value will be changed, then the different combination, each phase become the generate the different combination of different phases. Similar to the shift column operation, we will perform the shift row operation, in which also doing the same. And we see that the first row and the last row will affect the upper and the below columns, below face as well affect the. So the formula will also generate the same, where the lambda equal to 0 mean we are using the second and third row, and if the lambda value equal to 1, we say that we will use the first and fourth column. And here the case 1 is that IF value will be the 1, 3, 5 or 6. If we get the value of initialization phase of raw is 1, 3, 5 or 6, we will get the combination 5, 1, 6, 3. Whereas the case 2 is that if we get the value 2 and 3 initialization phase value of raw, then the combination will be the 5, 2, 6, 4. These is what are the combination. And after that we will get, after that the row rotation, we will get this value. Firstly we will generate the new matrix using triangular coordinate extraction technique. After that we apply the operation on this matrix of the shift column operation, and then we move forward to the shift row. After the shift row we will get the value like that. After that we will move for the modulo operation of the hybrid cube. In the modulo operation we will apply the modulus on the shift row operation matrices, and after getting the modulo we will see that we will get the lot of repetition in the matrices. The purpose of the modulo operation in order to get the unique matrices. Our target is to get the unique matrix. There is no, we will not find the combination where have similarity, or the attacker get the hint how to open that key. So for that purpose we apply the modulo operation. Wherever we get the repeated value, we will see here many repeated value, we will apply this definition. First we move from the top to less number. Like firstly, if we see the phase 1, firstly we see that how many times the 15 is repeated. We see that first one repetition is this, second one is this. As per the definition, on first repetition is that this is the first number, here is the first repetition. If the first repetition, we will minus the one number, like we say that 15 minus 1 is the 14. If then we check the 14 in the whole matrix, is this repetition? No. Then we check 13. We move forward until to the value of 0. When we get the value 0, if we still find that we have repetition, and then move to the another definition, which will the addition of one number wherever we find the repetition. After that we will find the matrix that is unique. Similar to that example, we apply all these operation to the all the key matrices in the hybrid cube. Here is the triangular key matrices. In the triangular key matrices, you have see that we divide the result receive in the shift operation of each phase. After this phase, we will manage the value of the rotation point. In rotation point 0, you see that the half of this value. If the rotation of point 1, we see that here is the full value, here is the half value, because half in the quarter 1, half in the quarter 4. Similarly, if we go to the rotation point we get this coordinate value full, and this one become half. Similarly, all the rotation point you have done the same things, and accordingly you will get the all coordinate value where the 0 and 1 form. Once we get the 0 to 15 value, what we are doing, we will get the 0 and 15 value, we just replace these values with the this unique matrix value. Like phase 1 we have we will done the triangular rotation, we will find the triangular rotation value of this phase. We suppose that this is the phase 1, we done this all the operation with the phase 1. After that we get the 0 to 15 value. When we get the 0 to 15 value, we will replace this value in the place of 0 here, we will replace the value we find the in the next triangular key matrix value. Similarly, if we see that 1, we replace the value of 1 here. Similarly, all the phase we will complete the value with the fill the value with the unique matrices. Similarly, we get the shift raw value of phase 2 and apply the same operation here, and after that we get the value and we replace that value. And at the end, the novelty of the key matrix of the key scheduling algorithm is that all the generated master key and session key of hypercube are invertible and suitable for the encryption decryption algorithm. In short way, we say that this in the end, this section calculate the value of key matrix that is generated with the shift raw operation using the rotation point, which are based on the unique matrix. The new key matrices are generated through the calculation of shift raw coordinate value based on the rotation point, and finally